Imagine standing on a cliff overlooking the ocean at sunset. The wind presses against your skin. The air smells of salt and distance. Beneath your feet lies rock older than bones, older than trees, older than memory itself. Now imagine this. What if the ground you're standing on is not just ancient, but recycled? What if cities once rose here, not of steel and glass, but of materials so distant in time that their remains are indistinguishable from geology? What if intelligence flourished, engineered, industrialized, and then vanished so completely that the planet swallowed almost every trace? And what if the only reason we assume we are the first is because we are too young to recognize the evidence? You believe civilization began a few thousand years ago. You believe industry began 2 centuries ago. You believe intelligence, technological intelligence, belongs to us. But the Earth is 5 billion years old. Human civilization occupies less than a blink, and in that blink, we have already reshaped the atmosphere, scarred the crust, altered the chemistry of oceans. So here is the unsettling question. If we disappeared tomorrow, how long would it take for the planet to erase us? 1,000 years? 1,000,000? 10 million? And if 10 million years passed, would anyone even know we were here? This is not science fiction. This is a real scientific hypothesis. It is called the Silurian Hypothesis. And once you understand it, you will never look at history or the ground beneath your feet the same way again. The idea begins not with aliens, not with mythology, not with Atlantis. It begins with geology. Picture Earth 300 million years ago. Dense forests stretching across continents, insects the size of birds, oxygen thick enough to make flames roar higher than today. No humans. No mammals as we know them. Just alien landscapes of ferns, amphibians, and towering swamps. Now jump back further. The Silurian period, roughly 440 million years ago. The land was mostly barren rock. Life clung to oceans. Primitive plants crawled onto shore like hesitant pioneers. It seems impossible. And that's exactly why the hypothesis is so dangerous to our assumptions. In 2018, scientists proposed a question. Not a claim, not a belief, but a testable thought experiment. If an industrial civilization existed millions of years before humans, would we even be able to detect it? Notice the shift. This is not asking whether one existed. It is asking whether our methods of detection are capable of finding one. And that changes everything. Because we assume the fossil record preserves the past faithfully, but it doesn't. It preserves accidents. Fossilization is rare. Civilization-level preservation is rarer. Steel rusts in centuries. Plastic degrades in thousands. Cities collapse into sediment astonishingly fast on geological timescales. Run the clock forward 10 million years. Mountains rise. Oceans advance. Tectonic plates grind continents into subduction zones. Concrete becomes indistinguishable from natural limestone. Roadways dissolve. Satellites decay and fall. Radioactive signatures disperse. All that might remain is a thin chemical scar in the rock, a strange isotope ratio, an abrupt carbon spike, a layer rich in synthetic compounds that future geologists cannot easily classify. Now pause, because that is exactly what we are leaving behind, right now. When we burn fossil fuels, we inject massive amounts of carbon-12 into the atmosphere. It alters the isotopic balance globally. We are also producing plastics, synthetic molecules, long-lived radioactive elements, and nitrogen spikes from agriculture. We are creating a geological signature. Future scientists, if any exist, would see our era as a sudden anomaly in sediment layers, a spike, a disturbance, an abrupt planetary fever. Now here is the twist. Earth's deep history contains several mysterious abrupt events: the Paleocene-Eocene thermal maximum, a rapid global warming event 56 million years ago, massive carbon injection, ocean acidification, species turnover. We attribute it to volcanic activity or methane release. That explanation is reasonable. But here's the uncomfortable thought. If another civilization industrialized 60 million years ago, would their carbon spike look any different from a natural one? How would we distinguish industry from volcanism after tens of millions of years of erosion? The Silurian hypothesis forces us to confront a brutal truth. Geology is not a perfect archive. It is a blender, and most evidence gets pulverized. Consider this scale. Modern human civilization, true industrial civilization, is roughly 200 years old. 200. That is 0.00004% of Earth's history. We assume uniqueness based on an almost invisible sliver of time. Now imagine intelligence evolving in the Carboniferous period, or the Devonian, or even earlier. It would not need to look like us. It would not need skyscrapers. It would only need energy manipulation and large-scale environmental impact. And if it lasted 100,000 years, far longer than our industrial era so far, and then collapsed, what would remain after 300 million years? Probably not fossils of smartphones, probably not intact buildings, but perhaps an isotopic fingerprint, an unexplained extinction, a strange mineral distribution. And here is where the idea deepens. Civilization is fragile. We tend to think of intelligence as a ladder, primitive to advanced, as if evolution inevitably trends upward. It doesn't. It experiments. It diversifies. It erases. For most of Earth's history, dinosaurs dominated. They existed for over 160 million years, vastly longer than humans. If one lineage of dinosaur had developed tool use, energy systems, perhaps even primitive industry, and then vanished in a mass extinction, we might never know, because the rock record would swallow nearly all of it. Let that sink in. The absence of evidence is not evidence of absence, especially across hundreds of millions of years. And yet, we stand here convinced we are first, confident, certain, but certainty in deep time is arrogance. The Silurian Hypothesis does not claim there was a lost civilization. It asks whether we are capable of proving there wasn't. And the answer is unsettling. We are not sure, because our detection methods are tuned for fossils and bones, not for ephemeral technological signatures buried beneath tectonic recycling. And tectonics is relentless. 2/3 of Earth's crust is younger than 200 million years. Anything older has likely been subducted, melted, transformed. Entire continents have disappeared into the mantle. If a civilization arose on a supercontinent 400 million years ago, that continent might not even exist anymore. Imagine building your cities on a raft that eventually sinks into magma. That is Earth. That is geological time. Now expand the scale further. Intelligence might not even require land dominance. An oceanic species, a reef-dwelling networked organism, a deep-sea energy-harnessing life form near hydrothermal vents. Our imagination is limited by our own form, but evolution is not. And now the question shifts from did one exist to something more profound. What does it mean that it could have? And we might never know. Because this is no longer just about the past. It is about us. If humanity vanished tomorrow, our greatest cities would become rubble in millennia. In millions of years, forests would reclaim everything. In tens of millions, tectonics would erase almost all surface traces. Our existence would compress into a faint geochemical whisper, a blip, a curiosity in stone, and perhaps far in the future, another intelligent species would study those rocks and debate whether the anomaly was volcanic or something more deliberate, just as we debate ancient carbon spikes today. You are living inside a geological experiment. Your species is writing a layer in Earth's crust, and the haunting possibility is this. Maybe we are not the first layer. Maybe we are just the most recent. And if that's true, then civilization is not a beginning. It is a recurring event, a temporary flare in the darkness of deep time. But the implications grow even stranger when we ask the next question. If civilizations can rise and vanish without leaving obvious traces, how common might that be? And what does that say about our future? Because the rock record may not just hide ancient intelligence, it may be hiding a pattern, a cycle. And in the next layer of this mystery, we confront something even more destabilizing, not whether we were first, but whether we are already approaching the same invisible horizon that erased whoever might have come before. The first time you truly understand deep time, something inside you shifts, not intellectually, physically. You begin to feel small in a way that has weight. Imagine compressing Earth's 4.5 billion year history into a single calendar year. January 1st, the planet forms in fire and collision. Oceans condense from steam. Continents drift like fractured ice. Life appears in March. Complex cells in August. Dinosaurs rise in mid-December. They vanish on December 26th. And humans? We arrive in the final minutes before midnight on December 31st. Industrial civilization, the last second. Now hold that scale in your mind, because the Silurian hypothesis becomes far more unsettling when you realize how little of that calendar survives in pristine condition. The geological record is not a high-definition archive. It is a shredded manuscript. Entire chapters are missing, pages fused, ink smeared by pressure, heat, and time. Two tectonic plates converge, one dives beneath the other. Rock melts, history dissolves. Imagine a city built near a subduction zone 300 million years ago. Towers, roads, power systems. Within tens of millions of years, that crust segment is recycled into magma, its physical memory gone, its atoms remixed into future mountains. We assume permanence because we live inside short spans. Geology does not. Now consider something else. Civilization does not need to leave statues to leave a mark. It only needs to perturb planetary systems, and planetary systems have rhythms, baselines, equilibriums that persist for millions of years until something disrupts them abruptly. When we examine past mass extinctions, we often see sudden carbon spikes, temperature surges, ocean acidification, biodiversity collapse. These events are dramatic, global, and fast on geological timescales. Take the event that ended the dinosaurs, the Cretaceous-Paleogene extinction event. An asteroid impact. A thin global layer rich in iridium, shocked quartz, a clear extraterrestrial fingerprint. That is what a violent external disruption looks like. But not all disruptions carry such clean signatures. The Paleocene-Eocene thermal maximum was different. Temperatures rose dramatically. Massive amounts of carbon flooded the atmosphere and oceans. Deep-sea ecosystems collapsed. It happened rapidly, within thousands of years, and recovery took over 100,000 years, thousands of years. On geological scales, that is instantaneous. We attribute this to volcanic outgassing, methane clathrate release, feedback loops, all plausible, all supported by evidence. But here is the razor-thin edge of the hypothesis. If an industrial civilization had burned carbon at large scale during that period, the isotopic signature, a shift toward lighter carbon isotopes, would look strikingly similar, because carbon is carbon. The rock does not record intention. It records chemistry, and chemistry cannot tell you whether the source was a volcano or a furnace. This is the epistemological trap. We look backward and assume natural causes because that is what we know, but our interpretation is constrained by imagination. If we had never industrialized, would we interpret modern carbon spikes as anything other than volcanism? You are living inside the reference model that shapes your interpretation of the past. Now take this further. Suppose a civilization arose 200 million years ago and lasted 50,000 years, a blink compared to dinosaur dominance. Suppose it reached modest industrial capability, fossil fuel extraction, agriculture, synthetic chemistry. Then it collapsed. War, climate instability, resource exhaustion, asteroid, supervolcano. It doesn't matter. After collapse, infrastructure decays rapidly. Steel oxidizes, concrete fractures, organic materials rot. Within 10,000 years, forests reclaim cities. Within 100,000, glaciation grinds structures into sediment. Within a few million, erosion spreads fragments across basins. Within 100 million, tectonics recycles much of the crust. The probability of preserving a recognizable artifact becomes vanishingly small. And fossils? Fossilization requires specific conditions: rapid burial, low oxygen, mineral infiltration. Most organisms that have ever lived left no fossil record at all. If an intelligent species had a small population, even millions, their skeletal remains might never fossilize in large numbers, especially if they cremated their dead, especially if their bodies were delicate, especially if they lived in erosion-prone environments. Absence of fossil evidence does not scale linearly with absence of existence. It scales with probability, and probability is ruthless. But here is where the argument tightens. The Silurian hypothesis proposes something testable. It suggests that rather than looking for artifacts, we should search for anomalies in sedimentary layers that resemble what we are currently producing. Synthetic molecules that do not occur naturally, unusual isotope ratios, long-lived radioactive elements like plutonium-244, plastic residues compressed into rock. We are already leaving microplastics in ocean sediments. We are dispersing aluminum at concentrations rarely seen in natural form. We are altering nitrogen cycles through fertilizer at planetary scale. If future geologists drilled into strata 100 million years from now, they would detect a sharp boundary, an abrupt transition marking the Anthropocene, a geochemical scar. Now imagine that scar buried beneath layers of time, partially distorted but still detectable. Would we interpret it correctly, or would we attribute it to exotic volcanism, unusual ocean chemistry, rare tectonic conditions? Our interpretations are narratives constructed from incomplete data. And here is the deeper philosophical tremor. We assume intelligence is rare because we have only one example, ourselves. But evolution repeatedly produces complexity. Eyes evolved independently multiple times. Flight evolved multiple times. Echolocation evolved multiple times. Convergent evolution is not an exception, it is a pattern, given hundreds of millions of years. Could intelligence capable of tool use arise more than once? Could it rise and vanish more than once? Dinosaurs dominated for over 160 million years. Mammals only gained prominence after their extinction. If the asteroid had missed, perhaps mammalian intelligence would never have flourished. Perhaps some theropod lineage might have developed increasingly sophisticated cognition. We cannot rewind and test. We only see the surviving branch. Survival bias masquerades as inevitability. Now feel the gravity of that. You are not necessarily the climax of evolution. You are a current expression, a temporary arrangement of matter and energy. And civilization, that shimmering web of satellites, fiber optics, skyscrapers, is less than a millimeter thick on the timeline of Earth. We imagine deep time as a straight road behind us. It is more like a churning ocean. Layers overlap, currents erase, storms rewrite coastlines. Even our moon, which seems eternal, is slowly drifting away from Earth by centimeters each year. Planetary systems evolve, magnetic fields flip. Ice ages advance and retreat. Continents collide and tear apart. Stability is an illusion produced by short perception. Now step back further. If industrial civilizations can be erased almost entirely in tens of millions of years, and if Earth has hosted complex life for over 500 million years, then statistically there has been ample opportunity. Opportunity does not equal occurrence, but it eliminates impossibility. And that is the core of the hypothesis. Not proof, possibility. A possibility grounded in geological humility. But here is where the stakes escalate beyond curiosity. If civilizations are difficult to detect after deep time, then our own legacy is far more fragile than we imagine. We speak of monuments lasting forever. There is no forever on a tectonically active planet. The Permian-Triassic extinction event wiped out around 90% of marine species. Entire ecosystems collapsed. It took millions of years for biodiversity to recover. The dominant life forms before that boundary are almost alien to us now. What if intelligence had emerged before that boundary? It would have been erased in one of the most catastrophic resets in Earth's history. Reset. That word changes the emotional temperature. Mass extinctions are planetary resets. They clear ecological space. They shuffle evolutionary decks. They redirect trajectories. Human civilization feels stable, but stability is conditional. And here the Silurian hypothesis subtly turns from past to future. Because if geological processes can erase advanced species beyond recognition, then permanence is not our destiny. It is not guaranteed that our story will be remembered. We might be a brief spike in carbon, a thin dark line in sediment, and then silence. But there is another layer of this mystery, one that pushes the question beyond Earth itself. Because if Earth can erase civilizations, what does that imply about our search for extraterrestrial intelligence? If planets recycle their surfaces, if industrial phases are brief, if detection windows are narrow, then perhaps the reason the universe seems silent is not because intelligence is rare, but because geological and cosmic time are relentless filters. And that realization leads us into something far more destabilizing than a lost civilization in Earth's past. It leads us to confront whether advanced life anywhere is almost always temporary. And if that is true, then the greatest mystery is not whether someone came before us. It is whether anyone lasts long enough to be found. The silence of the universe feels vast because you assume it is empty. But what if it is not empty? What if it is simply layered, like Earth's crust, compressed, rewritten, erased? When you look up at the night sky, you see stars that have burned for billions of years, stable, patient, enduring. And yet on the surface of planets orbiting those stars, change can be violent and abrupt. Continents shift, atmospheres transform. Species rise, dominate, and vanish. Now imagine this pattern not once, but millions of times across the galaxy. Civilization ignites, it industrializes, it alters its planet, it destabilizes itself. Through climate, warfare, resource exhaustion, cosmic impact, or something we cannot yet imagine. It collapses. The planet absorbs the evidence, and within a few 100 million years almost nothing remains. Not monuments, not radio signals, not artifacts drifting in orbit, just chemistry. A faint atmospheric anomaly, long dissipated, a geological whisper. You are living inside that window right now. A razor-thin interval where intelligence is loud enough to be detectable, by itself, and perhaps by others. But the universe is 8 billion years old. Your detectable phase has lasted barely a century. Think about that ratio. If another civilization rose on a distant world 200 million years ago and lasted 50,000 years, an extraordinary achievement by our standards, their signals would be long gone. Their satellites would have decayed, their planetary scars softened by erosion or tectonics. Even if we scanned their world today, we might see nothing unusual. The silence would not mean absence. It would mean timing. And that reframes the so-called Fermi paradox, the unsettling question posed by Enrico Fermi: where is everybody? Perhaps they were here, just not now. The Silurian Hypothesis, though focused on Earth, quietly dissolves a much larger assumption that intelligence leaves permanent monuments in the cosmos. It doesn't. It leaves phases, transient, energetic phases, like flares. Now return to Earth. Imagine drilling deep beneath the ocean floor, extracting cores of sediment stacked like pages of an ancient novel. Each millimeter represents thousands of years. Tiny shells, mineral grains, isotopic ratios, encoded memories of climate, chemistry, life. You are searching for anomalies, a sudden shift in carbon isotopes, a spike in heavy metals, a strange distribution of synthetic-like polymers. If you found such a layer 300 million years deep, would you recognize it as industry? Or would you write a paper describing an unusual but likely natural geochemical excursion? Science is powerful, but it is also constrained by models, and models are built from current understanding. Before we discovered nuclear fission, a thin layer rich in unusual isotopes might have seemed inexplicable. After we understood fission, we could interpret the natural nuclear reactor at Oklo as a self-sustaining chain reaction that occurred billions of years ago. Interpretation evolves. Evidence does not announce itself. And this is the quiet intellectual shock at the heart of the hypothesis. The past may contain signals we have already seen, but misclassified. Not because scientists are careless, but because extraordinary explanations require extraordinary evidence, and geology rarely preserves clarity at deep timescales. Still, the hypothesis does not claim hidden cities beneath rock. It does something more refined. It forces humility, because once you accept that a technological civilization could, in principle, be erased almost entirely over hundreds of millions of years, you must confront a sobering corollary: we are not guaranteed to be discoverable. Our skyscrapers will fall. Our digital archives will decay. Our satellites will burn in the atmosphere or drift into gravitational chaos. Even the Voyager 1 and Voyager 2, carrying golden records meant to outlive us, are vulnerable to cosmic radiation, micrometeoroids, and the slow entropy of materials. Given enough time, even they will degrade into silent relics. Nothing material is immune to time, and Earth is especially unforgiving. Its crust is restless, its mantle convex, its climate oscillates. The very processes that make it habitable also make it forgetful. Now consider a deeper possibility. What if civilization is not just fragile, but cyclical? Not in the sense of mythic golden ages and dark ages, but in planetary thermodynamics. A species evolves high intelligence, accesses concentrated energy, fossil fuels, for example. Energy surplus enables exponential growth. Growth alters climate. Climate destabilization challenges survival. The system enters crisis. Either the species stabilizes sustainably or collapses. If collapse occurs, evolution continues. Another lineage might rise millions of years later. The cycle repeats. Earth has hosted complex ecosystems for over 500 million years. That is enough time for multiple evolutionary experiments in intelligence. We cannot prove such cycles occurred, but we also cannot rule them out with certainty. And that uncertainty is not weakness, it is maturity, because it reveals something uncomfortable about how we perceive ourselves. We assume uniqueness because we see no competition in the present. But uniqueness in a single slice of time does not equal uniqueness across all time. You are looking at one frame of a 500 million year film. Now imagine that film containing multiple climaxes, each erased before the next begins. Civilization, then, is not a monument. It is a phenomenon, a phase transition in planetary chemistry and biology. When intelligence manipulates energy at scale, it shifts atmospheric composition, sediment patterns, biodiversity trajectories. That shift is measurable, but only briefly. After enough time, the planet re-equilibrates, the fever breaks, the scar softens. From orbit, Earth today glows with city lights. Radio waves leak into space. Industrial gases accumulate. We are obvious, if someone is watching right now. But zoom out 1 million years into the future, the lights are gone. The radio silence is complete. Forests blanket former megacities. Ice sheets grind continents. The Anthropocene compresses into a thin, dark seam between rock layers. And perhaps, another intelligent species drills into that seam. They find anomalies. They debate. They propose natural explanations. A few among them whisper a radical thought. What if this was someone? And most dismiss it as speculative. Just as many might dismiss the Silurian Hypothesis today. This is the final inversion. The hypothesis is not truly about the past. It is a mirror. It asks you to imagine being the ancient layer, to imagine your entire civilization reduced to isotopes and dust, to realize that geological time does not honor achievement, intention, or consciousness. It only records impact. And impact fades. But here is the quiet, almost paradoxical beauty in that realization. If intelligence can rise, vanish, and rise again, then existence is not a single miracle. It is a recurring possibility. Matter organizes itself. Energy flows. Complexity emerges, perhaps again and again. You are not necessarily the first spark, and you may not be the last. The earth beneath your feet could be layered with forgotten experiments in awareness. Or it could be that you truly are the first. The data does not yet decide. And that uncertainty is the point, because it shifts the burden. Instead of asking, were we first? The deeper question becomes, what kind of layer will we become? A brief chaotic anomaly, or the beginning of a continuity that refuses erasure? The rock will remember something, it always does, but whether it remembers you as a self-destructive fever, or as the moment a planet learned to sustain its own intelligence, that story is still being written, and you are inside it.